Hello, just want to talk about some sound driver things for a few minutes. Maybe someone's interested. I don't know. I wanted to talk about this for a little while. So in the last little clip and post on Twitter and the socials and whatever, I said that we could then insert new sound sequences and then replace entries in this big table of pointers. Now that's improved to where the whole thing is shiftable, provided that you make sure you know where everything's going to end up in audio memory so you don't run into other data and code and whatever. I've disassembled the last few things that needed to be disassembled to make that happen. So anyway, I'm trying to document this stuff, right? And I find this one. No, I think it is down here. Somewhere. Am I gonna find it really quickly? Probably not. What is one of the first things called here? Oh. No, I don't want that. Go away. This here. Okay. So before I go on yammering on about assembly, there's some context about this particular processor. So the SPC700, to put it really simply, is basically just a 6502 in a trench coat. Most of the same operations from the 6502 are there. It's just the opcodes, the numbers, the machine code numbers that translate to the instructions when the processor goes and interprets the stuff are different. So like for instance, a NOP, no operation, opcode, the opcode in the 6502 is hex EA. Here on the SPC700, it's instead hex 0 for the same operation, as an example. That and the mnemonics and the assembly syntax are completely different. But it's, for the most part, it's still the same basic set of operations, and they, for the most part, all do the same sort of things. A couple operations got removed and some new ones got added, but for the most part, it's the same sort of thing. There are some weird things, like there's a half carry flag now instead of a carry. I'm not really knowledgeable on like the internals of processors, but it seems like because of the Z80 has something like this. I guess it's like the arithmetic logic unit on this thing operates in 4 bits instead of 8 bits or something. So that's why it's like that. And when you, this is just something I noticed that I thought was kind of like, what were they thinking? When you pull a value off of the stack and put it into a register on the 6502 and its derivatives, the processor status flags get set right away. So like if it's non-zero, negative, overflow, whatever. Whereas in here on the SPC700, it does not do that at all. I don't get why. Kind of stupid. I'm sure there's maybe a good reason for it, but I mean, I like that functionality because you don't have to compare tests. You can, if you just need to figure out something like is non-zero or negative, you can do that right away. Here you would have to do a compare, I guess, to figure that out. But anyway, it is basically the same. It's just basically like the assembly syntax is funny, and there's some new operations that have been added, and a couple have been removed. So here we do increment y 9 times. Now what this routine is doing is, oh wait, actually no, there's a little more context on how this works. So as I did mention before, there's this thing called ARAM that I had to rearrange to put some new sound samples in. So that's audio RAM. There's 64 kilobytes of it, and the whole sound program, because there's no sound ROM, the whole sound program and all the sound data and all that needs to live in that 64K for the sound stuff to function. So everything takes up RAM then. You know, you really need to try to conserve RAM, because I think like ideally you'd want your sound program to be small, and then so you could have like all your big samples and sequences and stuff. So here I'm like, why is this taking up so much? Now, on like a 6502 type processor, doing it repeatedly like this isn't necessarily a bad thing. If you put this in a loop for 9 times, that would actually be slower. Like 9 times do this, that would be slower. If you did it in a loop with a branch, that's slower. And if you do it, if you unroll the loop, is what they call it, it's faster, but it does take up more bytes. But the thing is here, this is already in a great big loop. and you don't really need to increase y by 9 like this. So that can be improved. And there's also something with these two instructions here that can be improved as well. And there's this here. Now, when I went and looked at the audio code in a debugger, I found that every time the original Star Fox loads a new set of samples, it runs this. And what this does is, now the engine sound sample is special in that it's generated in real time. It's noise that's attenuated and whatever else to make it sound like the R-Wing engine. Yeah, it's neat. So here, and this is something I find out later is completely unnecessary, it overwrites index hex 20 in the sample directory, which is the big table of addresses to BRR samples and then what their loop point is, with the location of an ARAM. So there's two things here. One of these things can definitely be optimized, and then the other, is questionable. So what I ended up doing in Star Fox CD was this. So instead of I and Y 9 times, I'm using the 6502 instruction names just because it's easier for me to understand if I translate it to that. I think using those names is just better, I guess. So instead of doing that, I've used A and add 9 to it instead. So I push A to the stack to save whatever was already there. Then I transfer A to X. Now, the reason why it's X instead of Y is because of another optimization I did. I had to switch the places of X and Y, so their use is inverted from the original code. So I transfer X to A, and then I add 9. Now on the 6502, and probably here too, I'm sure, if you don't want to add the borrow, if carry gets set, you clear carry, and if you subtract, you set carry to not subtract the borrow. So if you don't want the borrow with add and subtract, you either clear the carry or set it. So I clear the carry so that the carry doesn't mess with the addition, and then I add 9. So then this value then gets put back into X, so I transfer A to X, and then restore what was in A before I went and did the math. So I pull A from the stack. And that takes 7 bytes and 16 cycles. The old code, which was just increment Y 9 times, was 9 bytes and 18 cycles. So we saved 2 bytes and 2 cycles. Not bad. And then here, because we switched the place of X and Y, the SPC700 has a special instruction that combines a decrement and branch if not equal into one instruction. It takes 1 less byte. So I can use this dbnz, decrement if branch if not 0 instruction to save 1 more byte. And then here I removed that whole thing to insert the address of the engine sound into audio memory because I ended up not needing to do that. I actually just baked that in directly. I only have 2 sound bins now. This is the one with all the samples. I just hard code that right into the table. We don't need to do that. So that saves a few bytes, and then I found a few more places. There was one here where this instruction was redundant and doesn't need to be done. I took that out, saves 1 more byte. And there was another where they use a jump instead of a branch. Branch always. And this isn't necessarily bad. Jump is good if you need to jump to somewhere in your code that's far away. But it's not. The label's right here. So I changed this to a branch always. Now the difference between a jump and a branch always is a jump is encoded as the opcode for jump and then the address of the destination. That's 2 bytes because 16-bit addresses, this is a 6502 type processor. Whereas a branch always does the same sort of thing, but a branch encodes 1 byte as a signed offset, 8-bit offset, either forward or backward in the program to wherever the destination is. So as long as your destination is within 127 bytes forward or backward from where you're going to wherever it is from, you can use it instead. Now this here it says cost 1 more cycle, but I think I got this wrong. Maybe the SP700 is just like this, but I was reading some 6502 stuff this morning, and it seems like only if you cross a page boundary, a page is every 256 bytes, or like I think like every hex 100 bytes. If you cross a page boundary, then it does take one more cycle to carry out the branch. But since this probably isn't over a page boundary, this should be fine. So this saves one more byte. So overall, we saved like 21 bytes, and then there's also one sound effect that I believe is actually for certain completely unused. Takes up 8 bytes, remove that too, so that's about 30 bytes saved of ARAM that was wasted before. So anyway, it turns out that in vanilla, there's only 3 bins that ever change the sample directory up to the index that the sound driver overwrites for the location of the engine sound. And that would be PSG Sound 2, SG Sound 2, and SG Sound 3. PSG Sound 2, I believe, is just the PAL optimized version of SG Sound 2. SG Sound 2 is the orchestra instrument set for Space Levels and Venom. SG Sound 3 is the band instrument set for Canaria and, most planet stages, besides Venom. As well as, I think, like, Out of This Dimension 2, maybe, I think. Does that use the band set? It might, I don't remember. So yeah, instead of pointing to, they just put some waste sample in here, pointer to that, like they didn't need, because it gets overwritten anyway, as I wrote here. Reserved for place engine sound will be overwritten. So I just hard-coded the pointer to the engine sound right in the sample table, or sample directory, because this gets copied into ARAM over whatever base address to wherever it is. So that this is exactly what that code would have written into audio RAM, but it's baked in. So that saves the 21 bytes, plus the couple other optimizations that I put in. And I tried this in vanilla, and what do you know, it works fine. So the whole thing with this is just stupid. It did not need to be done. And well, as for optimizations, I think that's just about it, because I've had a look at this, and it seems like the stuff that wasn't like specifically for Star Fox that was added like new for Star Fox is all pretty well optimized. This is really the only bit that I could find that was particularly bad. So yeah, that saves about 21 to 30 bytes. If you get rid of that one little sample, then it gets about 30 bytes. But just the code changes alone is like 21 bytes. So that's pretty good. And I did actually make a new sequence thing for phase mumbles. I kept the other one for the down, but I might have that for the help. Instead, there's each teammate, except for Fox and every other NPC, has 3 sequences for the voice. One's the regular one that you hear in most dialogue, and then there's the help one that plays when they're getting shot at and chased, and then there's the down when their ship goes down and it explodes. So I've reused the old one, and I showed him that clip for that, but I might make it the help one instead. And then I made a new one for the regular radio shot. I tried to mimic the one from Star Fox 2. Turns out I can't exactly, because excuse me, sorry, my mouth's going dry. That there's some kind of weird difference in Star Fox 2 sound driver, and I haven't pinned it down exactly yet from just staring at machine code and looking at a quick and nerdy disassembly. One thing, even though like Miyu's voice sequence is exactly what's found in Star Fox 2 sound data, the pitch is just slightly off. And then for Faye, there's this weird thing Star Fox 2 does. The F9, which is a opcode in the NSPC driver, which is for a pitch slide to note, somehow takes 2 parameters instead of 3. I can't figure out why this is just yet in Star Fox 2, so I couldn't use the original voice sequence for Faye. So I had to write up a new one that just sounds as close as I could get it. Overall, it turned out okay. So I'll go ahead and show you now. Engine sound works fine, as you can hear. That's the same as before. Yeah, it's not great, but it'll do, you know. It'll do. And this just repeats because it's just for testing sounds. That's all this is for. So, yeah, not bad. So that's even more room for new data. I mean, I already saved quite a bit more because there's a few sound effects that depend on samples that I don't load into ARAM anymore, like they're gone. Like the voice sequences for like the vanilla end sequence with the call with General Pepper, and the continue screen when you press continue and Fox says let's go. I took those out. Turns out those actually took up quite a bit of bytes themselves, so I commented those out. Yeah, along with that one unused sound effect that I'm pretty sure is unused. So that's even more room for new stuff. So yeah, exciting stuff. Save more memory. Clean up the sloppy mess that was there. Yeah. Sound driver, go vroom vroom. It's pretty good. So yeah, that's about it. Thank you for paying attention to my insane rambling. See ya.